Chapter 6 begins with the idea of impulse, and here's an example that goes along with that. Here we'll have a ball bouncing off of a wall. 350-gram ball with speed 20 meters per second approaches a wall. It then rebounds with speed 15 meters per second. What impulse was experienced by the ball due to the bounce? Well, here we have an initial time and a final time situation, and we're going to draw the pictures separately. At the initial time, here we have the wall, and the ball is approaching. I'm going to let the ball approach from the right. The ball is approaching, and has a mass of M, 350 grams. Right in the instant before it hits the wall, its speed is 20 meters per second. And then the final situation, after the ball has rebounded from the wall, there's the wall, and here's the ball. Now mass is still M, 350 grams, and it's rebounding, so it's bouncing off the wall, going opposite direction now, and that final speed is 15 meters per second. Well, let's do oops, and point out, as we like to, that before we can plug numbers into equations, we need the positive sense. And I'm going to let to the right be the positive direction, which happens to actually be why I let the ball in the picture come in from the right. Okay, so just repeating the diagram, the time initial, the time final. Impulse is defined, it's a vector quantity. It's the mass times the final velocity minus the mass times the initial velocity. That's also the final momentum minus the initial momentum. However, the motion as drawn is strictly in the x-axis, so I'm going to look at the x component of the ball, the velocity. And the mass, 350 grams, probably safer to use SI units here, so we'll change it to 0.35 or 0.350 kilograms and plug that in just a moment. The final velocity is the initial velocity, it's in the negative direction. So as a component, that's negative 20 meters per second. And the final velocity, now that's in the positive direction, so that's a positive 15 meters per second. The signs are very significant to this problem. So we'll substitute in 0.35 times the positive 15. Of course, you don't really need to write the plus sign. Minus the 0.35, but then times negative 20, and work that out to get about 12.25. And that's kilograms times meters per second. There's not a special SI unit for impulse or for momentum. And that's one little example.